Welcome to today's math video on understanding fractional exponents. Today we're going to look at what exactly 3x to the power of 3 halves means and clear up a common misconception. Let's start with the expression 3x to the power of 3 halves. A common misconception is thinking this means 3x squared times the square root of x. But this is not correct. So what does 3x to the power of 3 halves actually mean? Let's recall the meaning of fractional exponents. For any base x to the power of over b means the bth root of x to the power of a. So specifically for x to the power of 3 halves, this means the square root of x cubed, or equivalently, x to the power of 1 times x to the power of 1 half, which is simply x times the square root of x. Let's visualize what these exponents actually mean. If we look at the exponents on a number line, we can see that x to the power of 3 halves falls exactly halfway between x and x squared. Think of it this way. When we have x to the power of 1, we're multiplying by x once. When we have x to the power of 2, we're multiplying by x twice. So x to the power of 3 halves means we're multiplying by x 1.5 times, which is the same as multiplying by x once, and then by the square root of x. Now, let's apply this to our original expression. 3x to the power of 3 halves simply means 3 times x to the power of 3 halves. And since x to the power of 3 halves equals x times the square root of x, we have 3 times x times the square root of x, which simplifies to 3x times the square root of x. Let's understand why the misconception happens. Some students mistakenly think of x to the power of 3 halves as x squared times the square root of x. But that's actually x to the power of 5 halves, not 3 halves. Let's compare. X to the power of 3 halves equals x times the square root of x, which is x to the power of 1 plus 1 half. X squared times the square root of x equals x to the power of 2 plus 1 half, which is x to the power of 5 halves. So they're completely different expressions. Let's see an example with a specific value to make sure we understand this concept. Let's use x equals 4 as our example. For 4 to the power of 3 halves, we have 4 times the square root of 4. The square root of 4 is 2, so this equals 4 times 2, which is 8. But if we incorrectly calculate it as 4 squared times the square root of 4, we would get 16 times 2, which is 32, giving us the wrong answer. Now, let's see how this understanding applies in calculus. Suppose we're finding the derivative of y equals x to the power of 3 halves divided by 4x. Using the quotient rule, we get the numerator as 3x to the power of 3 halves plus x to the power of 1 half minus x to the power of negative 1 half, all divided by 4x squared. To simplify this, we need to convert all terms to a common form. Using our understanding of fractional exponents, 3x to the power of 3 halves equals 3x times the square root of x, which we can write as 3x squared divided by the square root of x. X to the power of 1 half is just the square root of x, which is x divided by the square root of x. X to the power of negative 1 half is 1 over the square root of x. Combining these terms with a common denominator of the square root of x, we get the numerator as 3x squared plus x minus 1, all divided by the square root of x. So our final derivative is 3x squared plus x minus 1, all divided by 4x times the square root of x. Let's summarize what we've learned today. First, x to the power of 3 halves equals x times the square root of x, not x squared times the square root of x. Second, when working with fractional exponents, remember that x to the power of over b means the bth root of x to the power of a. And finally, understanding these concepts is crucial when simplifying expressions, especially in calculus. Thanks for watching. If you have any questions about fractional exponents or other math concepts, feel free to ask in the comments.